Thank you. Super nice to be here. So I'm Vincent. I'm from France. I work for a pretty cool iOS app called Photo Room. And today I want to talk to you about what's new in iOS, but not iOS 18, but rather iOS 17, 16, and 15. So why this topic? It's because every WWDC is basically like this. You see cool new APIs being introduced, you're excited, but you can't use them because you need to support the current OS, the new OS, and only that one. And basically what happens is that all of the really big changes like async await, the new observable pattern, they're so big that eventually people start to use them. But all of the smaller APIs, they never really get that momentum. And even though they can be super useful, they tend to become overlooked. And once you can actually use them because you've bumped your minimum target, well, you don't know that you can use them because you don't know that they exist. So today we're going to try and right this wrong. And we're going to start with some new APIs introduced all the way back in iOS 15. So something like 3 years ago, almost 4 years ago. So I hope that more and more of you will be able to use these APIs. Let's start with a really nice method called formatted. So if there is one type that is super common in iOS engineering, it's date formatter. You give it a date format, and then you ask it to format a date into a string. But this component is very error-prone. There are actually 2 different mistakes in the code that I've put here, so maybe some of you have already spotted them. What are these mistakes? Well, first, if you put capital D, you're not asking for the number of the day in the month, but rather in the year, which is not what you want. Here we have the 61st of March, which doesn't make sense in most cases. And there is a second mistake, which is with the capital Y, where you're not asking the current year of the day, but rather the year in which the week started. It makes a lot of sense if you're doing banking and accounting and you're computing compound interest, but in most cases it's not what you want, and this one is extremely subtle because it will only trigger bugs towards the end of the year, or rather the beginning of a new year. But the good news is that there is actually a much better and much safer API introduced in iOS 15 called formatted. You just need to take your date, you call formatted on it, and out of the box you get a nice looking localized formatting of your date. Way less room for mistakes, still room for configuration, because, for example, you can say, okay, you want your date in numeric format and you want to omit the time. So very similar to what I was doing with a date formatter before, except that now there is much less room for mistakes. You can even ask, for example, for the month to be spelled out, if that makes sense in your use case. And you can even go for some more specific things, like if you want to ask for that actual number of the day in the year, you can ask for it, but you can see that the formatting kind of makes it look like that it's not really meant to be user-facing. And what's cool is that this API, this formatted API, is not just for dates, but it's also available for numbers. So you can ask to format a number and you don't need to use all of the printf style formatting. You just take your number, your double, you say formatted, you give the number of digits that you want to have, and it will spit out a result that you can then show to the user. And another option which is really nice is for collections, where you can ask them to be formatted, and you can choose what you want at the end. Is it or, is it and that saves you quite a lot of extra code to write. You've got all of that in one line and available since iOS 15. On a totally different topic, you also have in SwiftUI a great modifier called privacy sensitive, which you can apply to any view. And what this modifier will do is that as soon as the app leaves the first ground, then the content of the view gets hidden. So it's super useful if you have an app where some of the content can reveal something that users might not want to reveal, and the idea is to hide it so that when the user show their phone to someone, well, if the app was open back when they put the app in the background, the information has been hidden. Very sensitive apps, like banking apps, they tend to hide the whole UI, but this is useful if only a small part of your UI is sensitive. And you can also use it when you're showing widgets on the home screen, so that sensitive information gets hidden when the user is not actively looking at the screen. One caveat to be aware of is that it will not have an impact on screenshots. The idea is that a screenshot is an intentional action from the user, so they want to take the screenshot. If you want to hide a view during a screenshot, you need to use it with different APIs. There is one to get the event that the screenshot is happening, and then you can hide the view, but you can't rely on privacy sensitive for that. Next is toggle style with a style of a button. So you have the toggle view in SwiftUI, super useful when you want to implement an on-off switch, but in some cases, it would feel a bit weird to use an on-off switch. Like, imagine if you're building a music app, have this UI for shuffle or on-off is weird. You would like to have something that looks more like a button that has a pressed and a released state. Well, now you can do it out of the box. Just call the toggle style button, either on the toggle itself or on an encompassing view, and you will get this nice little built-in behavior. Something you could have built for yourself before using a button and some extra code to manage the state, but now it's a built-in API in SwiftUI since iOS 15. Now let's talk about iOS 16, so a bit more recent, but hopefully many of you in the room are fortunate enough that you can use these APIs in your app as of right now. First, let's talk about the easiest way to introduce some SwiftUI to a UIKit app with UI hosting configuration. So this is the typical kind of code that you would find in a UIKit app. It's configuring a table view. You have the same API for a collection view. And this is the function cell for row at index path where you configure the cell. Well, what you can do since iOS 16 is that you can set the content configuration of the cell to be a UI hosting configuration. It works very similarly to a UI hosting controller, except that it allows you to put a SwiftUI view inside a UI table view cell or a UI collection view cell. Super easy, makes it super easy to introduce SwiftUI to a UIKit app as long as it supports iOS 16 and above. And what's nice is that I showed you a simple example, but you can put virtually any SwiftUI view that you want, and you can even use the SwiftUI modifiers for behavior. For example, you can use the swipe actions modifier, and if the video starts, it will add the possibility to be able to do a swipe to delete, for example. So it can be quite powerful and can be a great way to introduce some SwiftUI to a legacy UIKit app that you still have to maintain. Next one is a really great addition for UI, UX, and the comfort of your user, and it's the ability for a text field to scroll vertically. So by default, in SwiftUI, text fields, they scroll horizontally, and whenever the content is a bit too long, it makes it hard for the user because the user cannot see the full content at once. And it's quite easy to overflow on a text field. If you ask for the name of a user, some people will have very long names. Same thing if you ask for an address, for example. But the great thing is that since iOS 16, you can just set the new parameter axis to be vertical. And just by doing that, then when your text field overflows, it will overflow vertically. And this way, the user can still see the full content, provided that there is enough of a height in the frame of the view, of course, but you can see that it's much better to interact with this new view as a user than the previous one. So if you can support iOS 16 and you have some entry inputs for your user in your app, you probably want to look for a way to use this API because it can be the kind of low-hanging fruit that can really make your app much nicer to be used. Next one, it's a small improvement, but can be very helpful, especially if you're prototyping apps for yourself, is the property gradient. Now you take any SwiftUI color, you can call gradient on it, and you get a gradient. So I'm not sure how much you can see it's a gradient with the video projector, but I put several colors, so it's a bit easier to see that way. And just call gradient on a color, you've got a gradient. Of course, if you work with a designer, the designer will likely give you exact color codes, but if you're just working on an app for yourself and you would like to have a gradient, you can get one, and you don't have to worry about figuring out which color codes you should put to create a gradient. Now we're getting closer to the modern APIs, but still iOS 17 is one less version, and I know that there are a lot of apps that support only current and previous versions, so hopefully several of you in the room can already start using these APIs as of today, and if not, maybe when iOS 19 drops in September, you will be able to use them. So first one is about content unavailable view. So I'm sure you're familiar with this view that allows you to still present some state in the UI when there is no content, which is infinitely better than just showing an empty screen and letting the user figure out what's happening. So I'm sure you are already familiar with content unavailable view because many iOS content creators talked about it at length, but there is a static property on content unavailable view that I wasn't aware existed until I started doing some research for this talk, and it's the static property search, which returns a specific, a specialized version of content unavailable view to be used in the context where the user is searching for something and the search yielded no results. And what's really nice is that in addition to being localized and everything, there is a version of this search view where you can give it as an argument the text that the user has typed in. This way, it feels really like it ties in super well with what your user has been doing, and the cost to implement this UI is extremely small because it's basically all built in. You just need to pass in a parameter, and that's it. You've got something that is really nice looking, and that also has the advantage of following the standard iOS pattern, so your users will understand what's happening when they see this because all of the Apple apps are already using something similar. Next, let's talk about another kind of view that gives you a lot of features and functionality for really not too much of an effort, and it's the view subscription store view, which lets you implement nothing less than a fully functioning paywall with absolutely no effort. So let's assume that you have the IDs of a couple in-app purchases. You create your subscript store view, you give it your product IDs, I put some configuration for the header, and automatically you get this fully functioning paywall that lets you make a purchase on the Apple Store, and that also displays all of the information that Apple expects to see when you're putting a paywall in your app. So it saves you a lot of time in implementation, but also in app review. And as you can see, once you've made the purchase, the paywall also shows you which is your current plan. You can see the little star that says your plan, and you can also use the paywall to switch to another plan. So it's really impressive the amount of feature that you get when using this view. The fact that Apple directly benefits because they take a cut on the purchases shows that when there is an incentive to make something nice, it can really happen. And I was really impressed to see how well this paywall worked. And you can even customize it. For example, if you want to add a button to restore the purchases, you can just add the modifier store button for restore purchases, and it will add the button, and the user can use it. And even better, if you want to have some analytics to implement a funnel to see how your conversion is going, something that's super common when you have in-app purchases, and even more so when it's a subscription purchase, you have two modifiers called on in-app purchase start and on in-app purchase completion, which will be called whenever the user initiates the purchase and then when the purchase completes. And so in these modifiers, you give them closure that will be called, and you can do a lot of things in these closures, including calling your analytics to register that each event has triggered. Next, let's move on to talking about scroll views. So scroll views used to be a big pain point in UIKit. They've become much nicer to use in SwiftUI, but some of their features had been lost among the ways, and they've been added back in iOS 17. So let's see what's possible now. So this is a typical SwiftUI scroll view. It's scrolled horizontally, and you can see that I can stop the scrolling at any place that I want. But sometimes it's not what you want. Sometimes you want to give some restrictions on how the user can scroll. For example, maybe you want to implement a paging where a user can only scroll by a given amount. It's something that used to be possible for scroll views in UIKit, and now it's also possible in SwiftUI. The way it works is that you're going to mark each view in the scroll view as a scroll target layout, and then on the scroll view itself, you will tell it how it should behave with respect to this target layout. So here I said scroll target behavior paging, and it will make it so that I can only scroll by an amount that is equal to the width of the scroll view. So hopefully the video makes it much easier to understand than when I try to explain it with words. And it's the same behavior that was available in UIKit, I think, ever since the beginning of UIKit. There are options to customize it. For example, maybe you don't want to impose on the width of the scroll view, which is something that you only do, for example, if you're showing several pages. But something that could be more natural is maybe to make sure that you are aligned with the beginning of a new view inside the scroll view. That's possible. You just say scroll target behavior view aligned, and you will get this behavior. And now when you stop scrolling, it will automatically align with the beginning of a view. So if you need to implement this behavior, you will definitely be happy to see that it's now built in, because as you can imagine, if you wanted to implement this by hand, it can be complex, and it can also be quite error prone and very hard to make sure that you've covered all of the possible cases. Next, let's talk about two APIs that are very useful because they allow you to not use a geometry reader, which can be a bit annoying because, as we know, geometry readers, they tend to change your layout in very subtle ways. First one is called container relative frame, and it's something that you can use whenever you want to do a relative layout. So let's say that you have 3 views. These views don't have an intrinsic size, such as colors here in this example, and you want to lay them out so that each of the view takes a third of the available space. Up until iOS 17 in SwiftUI, you would use a geometry reader to access the full height and then divide it by the number of views that you want to show. But since iOS 17, you can use, so yeah, this is what you would get as a result. And now you can use the modifier container relative frame. So notice that the geometry reader is completely gone. I say in this modifier that I want to display 3 views and I want them to be displayed vertically. And this modifier takes care of computing the full height, then the height of each view, and setting the corresponding frame, and you get this result that you see on the right. Another similar modifier is called visual effect, and you can use it whenever you want to apply an effect, a transform to a view that would require a geometry reader to work. So let me show you an example. I have this view where I'm displaying several rectangles of colors, and let's imagine that I want them to look like this. So as we go down in height, we have an angle, we have a rotation with an angle that is increasing. We can implement this with a geometry reader. We use the geometry reader to get the position vertically, and then we use that to compute the angle. But the problem with a geometry reader is that, as you can see, if I put a black background, you can see that the geometry reader breaks your layout a bit because it adds a bit of space at the bottom, and so you would need to build your view to compensate for this, and it's not great because it means that if you ever need to get rid or move the geometry reader, you will need to change a lot of your code, and it's kind of one of the pain points of using a geometry reader. The good news is that you no longer need to use a geometry reader in that case. You can use instead the modifier visual effect, which is very similar to a transform in the sense that it lets you change the way a view is displayed, but without changing the layout itself. And the difference with a transform is that you get, as an argument of the closure that you pass to visual effects, a proxy that, just like the proxy you get in a geometry reader, lets you access the position of the view here in the global coordinate space. So something super useful if you want to clean all of the places in your code where you have a geometry reader, and it does more harm than good. And finally, last example, little nice example if you ever need to animate changes in numbers. So let's see an example. So I have this view, and I have a button that's going to draw a new random number. And by default, since I said with animation, I have the default transition between two views in SwiftUI, which is a crossfade. But if I use the modifier content transition numeric text on my text, you will see that now I get a new kind of transition, which is much more visually pleasing when you're dealing with numbers. And what's really nice is that there is even a specific parameter that you can set. If you're looking to implement a countdown, you can say numeric text, but with the parameter countdown set to true, and you will see that now you get this very nice looking countdown effect. So if you ever need to implement a countdown in your app, now you have a way to make it quite visually pleasing without making too many efforts to implement the feature. And I see we're on time, and that's perfect, because that's all I had for you today.